All right, so today we're going to finish the last section of this unit. All right, so today we're going to talk about trigonometric functions of any angle instead of just angles on the unit circle. We'll talk about reference angles and evaluate some more trigonometric functions. All right, so here you can copy down kind of all of our notes. All right, so these are just the definitions, right? So the definition of trigonometric functions of any angle. So it says let theta be an angle in standard position with the point xy being on the terminal side of theta. All right, and r is equal to the square root of x squared plus y squared. All right, if that's the case, then this is how we can find all of our trigonometric functions. So sine. You can write the equations, but you don't really need everything on top, but you definitely need r is equal to x, the square root of x squared plus y squared. All right, and then also, of course, like tangent and cotangent here are blank. Of course, we know from our reciprocal identities that tangent of theta is just equal to sine of theta over cosine of theta. So if you have y over r divided by x over r, right, then this just becomes y over x. And of course, cotangent, you can either, really the easiest thing to do is just flip these, right? So we know that they're reciprocals. So cotangent would be x over y. Okay, now, and honestly, there's a much easier way to think about this instead of, trying to memorize all of that. All right. This, however, down here is very useful. All right. The signs of the trigonometric functions in the four quadrants can be determined easily from the definition of the functions. For instance, because cosine of theta is equal to x over r, it follows that cosine theta is positive wherever x is greater than 0, which is in quadrant 1 and 4. All right, so I'll move this up so that it's not, there we go. All right, so this is very important, all right? There's a very easy little acronym to remember this. You can, you don't really, you don't need to make it anything crazy detailed, right? I just always remember it like this. All students take calculus, all right? So in the first quadrant, all of our trig functions are positive, right? In the second quadrant, just sine is positive, right? In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Right, so I think that's the kind of the easiest way to do it. And then, of course, if it's not positive, it's negative, right? So where here sine is positive, we know cosine and tangent would be negative. Here tangent is positive, so we would know sine and cosine would be negative. And here cosine is positive, so we know sine and tangent would be negative. So again, if you just remember all students take calculus, all right, then that's fairly easy to get to. Now, of course, reciprocal functions just follow the same as their, reciprocal companion, right? Just because you flip a fraction, it doesn't mean that it changes the sign, right? So wherever sine is positive, then cosecant is also positive, all right? Wherever cosine is positive, then secant is also positive. And wherever tangent is positive, cotangent would also be positive. Okay, so let's put this to work. Again, all those formulas where you have y over r and x over r and y over x and all of that stuff, you don't necessarily have to remember all of those. Of course you can. It's not very difficult by any stretch of the imagination. All right, but there's actually another, in my opinion, much easier way to do it. All right, so for here, -2, 3. All right, we can go through kind of all of those formulas first, but then I'll just kind of show you the easier way. All right, so we know that r is equal to the square root of x squared plus y squared. All right, so this is 4 plus 9. So this is the square root of 13, which cannot be simplified. So we leave it as such. All right, so now we know that sine of theta is equal to y over r. So in this case, this would be 3 over the square root of 13, which we have to rationalize here. All right, so if we just multiply top and bottom by the square root of 13, you get 3 root 13 over 13. All right, so of course we can then just use the reciprocal here. Again, you can take the reciprocal of this, but then you're going to have to rationalize again. If you actually take the reciprocal of this pre-rationalized, then you don't have to worry about it. So this would be the square root of 13 over 3. You could also, if we think about it in terms of the formula, is just r over y. So, all right, cosine of theta is equal to x over r. All right, so in this case, we have -2 over the square root of 13. So when rationalized, -2 root 13 over 13. And its reciprocal, secant, we know would just be r over x. So in this case, the square root of 13 over -2. And finally, tangent of theta is equal to y over x. So in this case, that would be 3 over -2. And of course, cotangent is the reciprocal of that, so x over y, so -2/3. And that's it. All right, pretty straightforward, pretty easy. All right. But again, I told you that there's another even easier way to where you really don't have to memorize anything, right? So if we have the point -2, 3, right? -2, -2, 3 would be up here somewhere. All right, so if we just make our line here, all right, so our angle theta is actually this angle right here, all right? However, if we just make this a triangle, if we just drop a perpendicular straight down here, all right, then let's kind of think of this. What does this mean? Well, -2 tells me how far left I go, correct? So I just make this side of the triangle -2. 3 tells me how far up I go, right? So this side of the triangle is +3, right? And then, well, how do I find this piece of the triangle? Well, I can just use the Pythagorean theorem, right? A squared plus b squared equals c squared, right? So that's essentially what we do when we find r, right? R is equal to x squared, r squared is equal to x squared plus y squared. So then when you take the square root of both sides to get your r, okay, so you just use the Pythagorean theorem, and here, this is the square root of 13. All right, well, now if we think of this interior angle now as theta, we can just use SOHCAHTOA, right? So sine of theta is equal to the opposite over the hypotenuse, right? So 3 over root 13, which is 3 root 13 over 13. Right, so we get all of the exact same answers. Whoa, what just happened? Okay. What is going on? Seriously. Okay. There we go. All right. That was weird, but all right. So we would get all the same things, right? And then of course cosine is equal to adjacent over hypotenuse. So negative 2 root 13 over 13. And so on and so forth. We're just going to get all of the exact same things here, right? Tangent is opposite over adjacent, so on and so forth. So if you don't remember these formulas, right, the y over r, the r is equal to the square root of x plus y, x squared plus y squared, right? Like all you have to do is make a triangle and use SOHCAHTOA. All right, why don't you guys go ahead and try this one? Okay, so instead of using all of those formulas, I just created a triangle here, right? Put my point for -5 here. 4 tells me how far horizontally I'm going. -5 tells me how far vertically I'm going. And then you can just use the Pythagorean theorem here to get the hypotenuse, right? So my angle theta is always the angle here that is made by the origin. All right, so all we have to do, sine of theta, sine is equal to opposite over hypotenuse. So -5 over root 41, which is going to equal -5 root 41 over 41. All right, of course, cosecant is simply the reciprocal of that. Let's flip this piece, it's a lot easier. So root 41 over -5. All right, cosine of theta is equal to adjacent over hypotenuse. So 4 over root 41, which is 4 root 41 over 41, right, which means secant is its reciprocal. Just flip this again, root 41 over 4. All right, tangent of theta is equal to opposite over adjacent, so -5/4. So cotangent of theta is just its reciprocal, -4/5. Good times. Okay. So given that the sine of theta is equal to -2/3, right, and tangent of theta is greater than 0, find the remaining trig functions. Okay, so we need to figure out what quadrant we're in here, because that's going to determine the signs of the trigonometric functions. Okay, so we know that all students take calculus. All right, so where is sine negative but tangent positive? All right, well, this is quadrant 1, 2, 3, 4. So we're down here in quadrant 3. Tangent is positive, but sine is negative. So we're in quadrant 3. All right, so let's just go ahead and say that here's quadrant 3. All right, let's just go ahead and make an angle in quadrant 3. Son of a bitch. All right, so here is my theta, always with the origin there. Sine is opposite over hypotenuse. All right, now we can tell which one of these, the 2 or the 3, is negative. Simply, for one, the hypotenuse will never be negative. All right, but here, because I'm going to the left, this value will have to be negative, and because I'm coming down, this value will have to be negative. All right, well, now we can just use the Pythagorean theorem. All right, so the square root of -2 squared, which is 4, plus 3 squared, which is 9. So the square root of 13. So this is the square root of 13. All right, so we already know sine, they gave us that. All right, so we can also very easily find cosecant. All we have to do is flip a sign. All right, cosine. All right, cosine, we know is adjacent over hypotenuse. And we do have to make this negative. All right, so negative square root of 13 over 3. All right, which means that my secant, all right, I would flip this and get -3 over root 13, which is equal to -3 root 13 over 13. And tangent of theta is equal to opposite over adjacent. So this will be a negative over a negative, so it's going to be positive, and we'll have 2 over root 13, which rationalized is 2 root 13 over 13. All right, and of course cotangent, we just take the reciprocal of that. Much easier to flip this. So just the square root of 13 over 2. All right, so we do have to be mindful here when you get problems like this, that this just between looking at this sign and what they tell us here helps us determine which quadrant we're in, right? Which helps us determine the signs of these things, right? So, and really, if you don't want to put the signs in the triangle, that's fine, as long as you remember all students take calculus, right? So I know, okay, well, tangent and cotangent are going to be positive. Everything else is going to be negative. All right, go ahead and try this one. All right, so we do have to be mindful first that cosine is positive and sine theta less than 0 means that it's negative. All right, so where is cosine positive and sine negative? And that will help with your signs. All right, so let's go ahead and take a look. All right, so again, if we think about our all students take calculus here, all right, cosine is positive and sine is negative, so I'm down here in quadrant 4. All right, so I'll just make an angle here in quadrant 4. All right, so my theta, of course, always here by the origin. So cosine is adjacent over hypotenuse. All right, and again, we know that this is positive because I'm going to the right. All right, so I can do a squared plus b squared equals c squared. All right, so b squared will equal the square root of c squared minus a squared, which will be the square root of 40. All right, which can be simplified. This is 2 square roots of 10. All right, so whenever we can simplify it, we do want to. All right, so this is going to be 2 square roots of 10, and it's going to be negative, right, because I'm coming down. All right, so sine of theta is equal to opposite over hypotenuse. So negative 2 root 10 over 7. So cosecant, we would flip that and get negative 7 over 2 root 10, which then we would have to rationalize. So we'll get negative 7 root 10 over 2 times 10, which will be 20. All right, cosine we were given. So secant is very easy to find. We just flip it. And finally, tangent, all right, is opposite over adjacent. So negative 2 root 10 over 3. So cotangent, we flip that, and we get negative 3 over 2 root 10, which rationalized is negative 3 root 10 over 20. And that is it. Okay, so now we're going to talk about reference angles. All right, so we have our regular angle theta, all right, and we have our reference angle, which we call theta prime, which has this little apostrophe above it. Okay, so these are just really easy formulas as a way to find your reference angle, right? So if you're in the second quadrant, all right, all you have to do is take pi or 180 and subtract your theta. All right, if you're in the third quadrant, right, you take your angle minus pi or 180. And if you're in the fourth quadrant here, all you have to do is take 360 or 2 pi and subtract your angle. All right, so I'll give you a minute to get that down, and then we'll look at some examples. I mean, I would. These are definitely notes that you would definitely want. so a couple of things that we do need to keep in mind when talking about reference angles. All right, one, reference angles, theta prime, all right, is always going to be between 0 and 90 degrees. All right, or in radians, 0 and pi. I'm sorry, pi over 2. All right, so, and it always has to be positive, always has to be, 90 or below. All right. So when we take a look, really the easiest way to do it that I think about it is see how basically you're always going to or from the x-axis, right? So it's basically, I just think of it as the fastest way to x-axis.
Hypothetically, there was, you were in quadrant 1, is there a way to get the reference angle?
It's whatever that angle is. Yeah, like since quadrant 1 is between 0 and 90, you don't even have to, like, the reference angle is the angle. Yep, absolutely. Okay, so let's go ahead and take a look here. So,
the other one?
Say that again.
Can you go back?
Yep, absolutely. Okay, so here we have 300 degrees. All right, so 300 degrees would be down here somewhere. All right, so theta prime, all we have to do is say, okay, what's the fastest way to the x-axis? Well, fastest way to the x-axis is to go here, which would take me to 360 degrees. So how far would I have to go? Yeah, 60 degrees. Done. Right over. Yeah, it's that easy.
Golly, from all the writing, I thought it was going to be hard.
Right. It's not. And then 213 degrees would be somewhere over here. All right, so again, essentially the fastest way to the x-axis is right here, right, which was 180. So from 180, how far would I have to go to get to 213?
33.
Yeah. That's it. All right, negative 135. There's a couple of ways that you can think about this. All right, so negative 135 would be over here somewhere. All right, we're just going in the negative direction. All right, now if you don't like negative 135, just find a coterminal angle, right? Just add 360 to this thing. All right, and that's going to be, what, 225? All right, so this thing is the same as 225 degrees. So again, the fastest way to the x-axis is right here, right? Yeah. Of course, this is a repeat. We don't need to do that again. All right, and then 144. All right, so 144 is going to be over here somewhere. All right, so again, I'm trying to get to the x-axis. Fastest way is right here. So I'm trying to get to 180 basically. So how far would I have to go?
36.
Yep. Done. All right, so reference angles, not terribly difficult. Okay. So now we're going to talk about doing the same thing, but in radians. Okay. Radians are a little bit trickier, all right, but it's still not bad if you kind of think of them in terms of approximation, all right, or you can just memorize those formulas that you wrote down at the beginning. But I still think of them in terms of just the fastest way to the x-axis, all right. So kind of what we need to think about here is, where are these? Okay, well, in radians, right, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then we're back here at 2 pi. Okay, so we kind of want to think of decimal approximations for this, right? Well, pi is really easy. We know that's just 3.14. All right, which means 2 pi is pretty easy, right? You just multiply that by 2 and you get 6.28. Right, if you cut pi in half, right, well, half of 3 is 1.5, half of 0.17 or 0.14 is 0.07. All right, so this is 1.57. Of course, 3 pi over 2 is really just pi over 2 plus pi, right? It's 1.5 pi. So add these two together, and you're going to get 4.71. Okay, so now we can kind of think of it the exact same way as what we were doing before. So 1.7 is obviously going to be up here somewhere.
The bottom one is 3 pi over 2, right?
Yes. Yes, sir. All right, so obviously my fastest way to the x-axis is going to be here. So I'm at 1.57, and I need to get to 3.14. So I'm sorry, I'm at 1.7, and I need to get to 3.14. So how far do I need to go? 1.44. Because 1.7 and 1.44 equal 3.14. Does that make sense? Okay. So, I mean, and that's really it, right? So 2.3 would be over here somewhere. So I'm still trying to get to 3.14. All right, so I have to go 0.84. I would definitely change these to positive angles, right? So if we just add 2 pi, which is 6.28, all right, we're going to get, let's see, 4.78. All right, so 4.78 would be down here. All right, so I'm trying to get to 2 pi. All right, so it's actually going to be 1.5. Negative 2.8, I would do the same thing, so add 6.28. All right, and when you do that, let's see, 3.2, 3.48. All right, so 3.48 would be down here somewhere. So I'm trying to basically go back to the x-axis here. So I'm trying to get back to 3.14. All right, so I would have to subtract 0.34. And that's reference angles. Yeah, it's always going to be positive. Technically, we want to say, like, how far would I go from the x-axis to get here, but I just subtracted, and I don't, you just know it's always positive. Reference angles are always positive.
I have a question.
Yep.
So what if your reference angle is like on the x-axis or the y-axis?
That's perfectly fine. Like it would just be, if it's on the x-axis, then your reference angle is going to be 0. If it's on the y-axis, your reference angle is going to be 90 degrees or pi over 2.
Okay.
Make sense?
Yep.
Cool. Good question, though. All right. So, okay. Let theta be an angle in quadrant 2 such that sine of theta is equal to 1/3. All right. Find cosine of theta using trig identities. Okay. So we're in quadrant 2, and we know all students take calculus. All right. So in quadrant 2, I know sine is positive, which obviously it is here. They gave it to us. All right. And we're trying to find cosine. What is cosine going to be in the second quadrant? I'm sorry, in the second quadrant. Positive or negative? Negative, right. So we just have to remember, to make sure that we make cosine negative. Now, it says using trig identities. Okay, so we can't just draw a triangle like we did just a little bit ago. All right. So one of our trig identities that has sine and cosine in it is sine squared theta plus cosine squared theta is equal to 1. All right. So we know that sine is 1/3, so sine squared is 1/3 squared. All right, plus cosine squared theta is equal to 1. 1/3 squared is simply 1/9. Of course, 1 is the same thing as 9 over 9. So now I can subtract this easily, and we get cosine squared theta is equal to 8 over 9. All right, well, I don't want cosine squared theta, I just want cosine theta. So I'm going to take the square root of both sides here. So cosine of theta, whoops, not cosine squared, cosine of theta. All right, so when we take the square root of a fraction, we can take the square root of the top over the square root of the bottom. The square root of the bottom is obviously 3. All right, the square root of 8 can be simplified because 4 goes into it even. So this is 2 square roots of 2 over 3. And we said that we're in quadrant 2. And we said in quadrant 2, cosine has to be negative. So I have to make that negative.
Didn't we do this on our delta method?
I don't know if they told you about quadrants and stuff. They did? Then yeah. Mm-hmm. Yep. Yep, so good times. Go ahead and try this one. All right, so let theta be an angle in quadrant 3 such that cosine of theta is equal to negative 5/13. Find secant of theta and tangent of theta using trig identities. All right, so secant is very easy. All right, but you'll have to find something else in order. Well, actually, no, you wouldn't.
Wait, so what would I have to do? Wouldn't we just have to find sine and put it?
You can. Well, secant is the reciprocal of cosine. So to find secant, all you have to do is flip cosine, right? And then to find tangent, there's a couple of different ways you could find tangent. You could find sine first and then do sine over cosine, but you really could just use the Pythagorean identity that says 1 plus tan squared theta equals secant squared theta. And since you already have secant, then you could just solve for tangent. Does that make sense? I know that was kind of a lot there to say in words, but Okay, so let's take a look. Like we said, secant of theta is very easy. It's simply the reciprocal of cosine, so negative 13/5. All right, and then we have the Pythagorean identity that says 1 plus tan squared theta is equal to secant squared theta. So we're looking for tan, and we know secant. So negative 13/5 squared. All right, so negative 13/5 squared is 169 over 25. All right, so I'll just make this 25 over 25. All right, so now we can subtract 25 over 25 from both sides, and we get tan squared theta is equal to 144 over 25. So now we take the square. Yep, exactly. So we take the square root of both sides, and we get that tangent of theta is equal to 12/5. All right, now we do have to be careful. All right, it says that we are in quadrant 3, right? So in quadrant 3, all students take calculus. All right, so tangent is positive, so we can go ahead and leave it positive here. Good times? All right. Sure. All right, and that's it for today. All right, so we can go ahead and stop here. I'll stop the video here.